Okay, now we're going to go through assignment set 2, section B, question 1. So a pendulum clock as shown in figure 1.1 using many buildings. The time shown in the clock depends on the movement of the pendulum. So this grandfather clock at the section over here actually has a pendulum movement like this. So it says that the pendulum bob takes 2 seconds to travel from the highest point X to the next highest point Y. Okay, do take note, an oscillation is actually going from the left to the right and coming back to the original position. Okay, so 2 seconds is actually half an oscillation. Right? Half a complete oscillation. So they ask you determine the number of oscillation of the pendulum before the minute hand shows a change of 1 minute. So they are just asking you number of oscillation in 1 minute. It is just what they're trying to ask you. So you know half an oscillation takes 2 seconds. So what it means that I know that one oscillation will actually take 4 seconds. Now, so number of oscillation in 1 minute. So 1 minute will just be equals to 60 seconds, which is 1 minute divided by 4. So you have 15 oscillation. So number of oscillation, 15. Now, state how the mass of the pendulum bob affects the period of the pendulum. Now, this one you just need to remember that the period of the pendulum is only affected by two things. First one, it is the length of the pendulum. So it's how long this segment is. Okay. Second thing, the period of pendulum is only affected by the gravitational field strength, G. So explain how the mass of the pendulum, okay, mass of pendulum affects the period. Answer is, okay, it does not affect. Okay, mass does not affect also. Mass does not affect the period. Now, next one. Part C. Suggest why the pendulum clock is not as reliable as electronic stopwatch. Now, if you look at it, this whole system works in such a way that when it's at the highest point, it has GPE. When it starts moving across, the GPE actually is converted to KE. At this point, the lowest point over here, the KE is at the maximum. Okay, then after when it goes back up, it converts back to GPE. So GPE to KE to GPE, and then it will come back. So it's about conversion of energy. Okay, if there's no energy loss, the system will be reliable and it will just keep going on. But as we know that in real life, the energy will never be just between GPE and KPE because there are moving parts. Okay, at the grandfather clock here, there are moving parts over at this part. So what's going to happen here is that friction, because the moving parts actually causes friction. So friction will actually slow the pendulum down, slows down the pendulum over time. Okay, so this is for question 1.